In example 3, we've got a classic tree problem. Love these. We're going to actually do this in class if you're lucky enough to be in my pre-calculus class. We're going to go outside and measure the heights of stuff. So in this problem, you're attempting to measure the height of a tree. You walk 15 feet away from the tree, and the angle of elevation to the top is 56 degrees. We want to know how tall the tree is. So one of the things we can do with trigonometry is we can measure stuff that's too hard to measure on its own. Like you could probably put a string all the way to the top of the tree if you got someone to climb the tree and go all the way to the top, or had like a really long ladder or something of that sort, but it's really not practical to do that. We could just go to the base of the tree, walk away, and then look up and see what the angle measure is. So we'll draw our diagram here, and then I'll make this the top of the tree right here. So we're going to go to the top of the foliage there, and the problem says we walk 15 feet away from the tree, so we're here now, the tree is there, and I suppose we're imagining ourselves just on the ground. You would have to figure out how tall you are if you looked up, so let's just imagine that we're laying on the ground, and for some odd reason we're able to measure right from the ground all the way up. Of course, in the real world you have to take into account some other variables as well. And that angle is 56. It's the angle of elevation. Remember, we always measure that from the horizontal. We want to know how tall the tree is. So we could call this T for tree or H for height or whatever. I'll use H, just don't confuse this with the hypotenuse. So we'll let H equal the height of the tree. Some of these complicated ones, this one's not too bad, but if you're in a complicated problem, it's a really good idea to, if you haven't drawn a diagram especially, to write down what your variable stands for. So when you solve for that variable, you can go back and go, oh yeah, that's the height of the tree. And it's totally going to be in feet here. So the unit will be feet. You'll see here that we have the H, which is the opposite, and the adjacent side. So we're going to use tangent with this one. The tangent of 56 degrees is equal to opposite over adjacent. We'll ignore the feet. We know what our final answer is going to be. If you want to leave them in there, you can. So we'll multiply by 15 on each side. That gives us H as 15 tangent of 56 degrees. So we'll get that old trusty calculator out here and see if we can enter this in. Tangent 56. If you get a really weird answer, you're probably in degree mode, or excuse me, radian mode, so just go ahead and check real quick. It only takes a couple seconds or a second or two to check, and we are in degree mode. So 22.2 would seem like an acceptable answer. So H is about 22.2 feet. That does make sense in the context of the problem here. This angle up there is going to be 34. This one's a right angle, of course. And so if we're looking at this logically and rationally, we would say that this height has to be bigger than this 15. Not a ton bigger, because we've got 34 degrees and 56, but a little bit bigger. And we've got 22.2 here.